Hello, good evening, sir. This is Sagar Gupta. My seminar topic is FPGA based switching circuit for low level impedance measurement using multiple input, multiple output system, also called as a EIT measurement, electrical impedance topography measurement. So here is my first slide. This is the outline of my slide which I covered in my slide. First is the principle of EIT, means what is the principle of these techniques. In EIT techniques, we are using some electronics designs. So I design one circuit for this EIT which is used in the background of the measurement. I will explain the input as well as the output phenomena in the designed circuit, how the source are get entered into the our load and how we are getting the output from the load by the Arduino command. And one of the most important slide is the mathematical phenomena, mathematical model of the EIT measurement techniques, and then I will tell you the multiple frequency. If we are applying the multiple frequency to the any body, then how the image are changing, and after that my slide will end with the conclusion. So here is the my first slide is principle of the EIT. Here I will tell you what is the EIT and what this circuit showing. So EIT is a approach to reconstruct a cross section impedance image of the body. This EIT techniques of this EIT technique is better than the other techniques which are using in nowadays like X-ray, CT in terms of the low cost, like 1,000 times less cost have the EIT techniques of imaging of any body parts. And in terms of the free radiations also, because there is a no ionization, starts, no ionization take place by these EIT techniques. So you can see the in the diagram, you can see in this diagram like this is the my body or subject under test, in which some of electrodes are encircled on the on this body, and these electrodes are encircled across this body, and we are applying the current between the two electrodes. The point is this: how am I getting the our outputs, our measurement from this uh, circuit phenomena? So that's I am telling you, like we are applying a current source between the two electrodes which are connected to the body, and we are measuring the difference voltage as output with the remaining electrode, as you can see from here. So once we have a number of voltage output from this measurement, then this all measured difference voltage of data are getting saved into the CPU, and with measured data of voltage we apply some algorithm, and after that the algorithm helps to reconstruct an image in the my desktop. Oh, so uh, you can see the we are getting the voltage as our measure data, and we are transferring the data into our CPU, and algorithm will use which help to reconstruct the image in my display. You can see here. So the body has a conductivity also, homogeneity. The body is not so plain, so homogeneous. The conductivity changes with this distance. So all we will discuss further. So in the next slide, in my next slide, I have a one picture. I have one a picture. You can see that here the electrodes are encircled on the chest of his his body, uh, and what we are trying to get from this electrode, like we want to see the changes in the volume of air and blood that occurs with the breathing as well as the circulation of bloods. So which part I want to construct the image, we will apply, we will encircle with the electrodes with and the electrodes are connected with the some electronics gadget, as well as the display. The electronics gadget will do all the work which I have done in the background, like algorithms, and all work will done by this electronic gadget. And after that, after applying the algorithm, are going to get the image in this display. So this all I have taken from one of the research paper whose writer is written is there here. So we applied the electrode, we encircle the electrode across this body part, and we are going to get this right side image in the our display. So I will explain the how and why the display, why and how this display occurs, and what is the uh, how what is this, which part of the image is this. So in the image part there is a two parts. There is a two parts. Upper parts is the heart image, and the bottom parts is the lungs image. I will tell you before telling. I will tell you something before telling about uh, this image. So there is a lungs in the bottom side, there is a heart and upside, and we know that when the ventricles in the heart are contracted, the blood are moves from the heart to the lungs. When two phenomena occurs in the heart, when ventricles are contracted and when ventricles are filled with the blood. When it's contracted, then all the blood will go to the lungs, and then come another thing, when the ventricles are filled with the blood. So we are getting the image by changing, by we are getting the image depending upon the conductivity of the that body part. So we are what we are applying, we are applying the current, we are getting the voltage, and this I will get a voltage depend upon the conductivity of the that part. So I when a heart when ventricles in the heart are contracting, then the admittivity of the heart will decrease. At the same time, the admittivity in the lungs part will increase because the all blood are going into the lungs. This I can this I can also explain by this diagram which is shown here. This is the upper diagram of the heart, and lower diagram is the lungs of the lungs. So in this diagram is between the admittivity versus the time. So you can see here when the you can see here admittivity are rapidly decreasing here in this case, in this area. Why? Because the ventricles are contracting in this zone. Admittivity decreases, as and at the same time our admittivity increases in the lungs, because the blood are coming from this heart to lungs. I wanted to tell you like that admittance are changing because of we are getting the different uh, voltage. So because of the changing in the conductivity and the particular part, we are getting the our image. So I put a image for in this slide for telling uh, is is this at the same time when the admittance of the heart is decreasing because the blood because ventricle are contracting, so our admittivity is decreasing. At the same time, admittivity is increasing in the lung side because the blood is coming from the heart to the lungs. So this all depends upon the conductivity, admittivity, which both are the same. So the next slide, I have this circuit is completely drawn by me, designed by me. This is I did not take any help of others. I one picture is given by the Vasali ma'am, but I did not copy because ma'am was using the 16 electrode, and the I used 20 electrode. So let me come in the slide. So here is the 20 electrodes load I have designed with the some resistance, because I have to make some load which have a uniform structure. So 20 electrodes load is this, and this part is the 1:32 demux. I have used the 1:32 pins of demux, where I will use only the 20 pins, because this my electrode has only the 20s wire and output. This is the current source, and this multiplexer will get command by this Arduino, and Arduino, and this is the amplifier. This is the amplifier, or differential amplifier, and this is the gain amplifier, which is connected to the Arduino. One by one I will explain how the input phenomena have taken place, as well as the output phenomena have taken place. So in the next slide, this is the input phenomena. I have put a load here because I have less space, so I cannot put the previous load of a screenshot here, so I put a load like this only. So in the from this load we are getting the 20 wires, means the 20 electrodes of output. How the input from take place, means this is the current source. So we know from the previous slide that I have to give the current between the two electrode at a time. So there is a 20 electrode are connected to the mux. So 20 electrodes are connected to the mux. So at the same time I need to active only two wires, from which I want to connect my the current source, voltage control current source. So let's say I want to connect my current source between one and the second electrode. So I will give command to my mux one from this Arduino key, Arduino, that key choose the one electrode, which is chosen by changing the select lines value of the mux 1, and in the same manner we will give command to the second mux also by selecting the value of the select line of this select line of the mux 2. So major thing is this: we have to control the outputs of the mux, from where I have to connect the voltage or current source, that depends upon the uh, code given by the Arduino. So the output phenomena is really uh, really interesting because we are getting the out we have applied the current source between the two electrodes, and then we have a output at every we have a output as a voltage with all electrodes. So one by one I will collect the difference voltage between the two electrodes with the help of by giving the command from Arduino to Mux, and the Mux will decide two uh, uh, which two electrode difference voltage I wanna get from this load. So by selecting the select line of the marks, we will decide uh, which electrode are going to give the uh, voltage at a time to the this differential amplifier. So we have applied the current source between two electrodes. So one by one, I need to take the voltage from the another electrode. So I will get the I will get the 19 voltage. I will get the 20 different voltage from this load when we applied the current source between the one and second electrode. If once we have measured all the voltage, then we again repeat this process by putting the current source to current source between the second and third electrode, and then we will uh, measure the data with remaining outputs, and then and this process will repeat again, like we will again will uh, put a current source between the third and fourth electrode, and we will get all the difference voltage from the all electrode. So means we at the last we will have the number of the measured output voltage. That output voltage are going to help really that all the measured data are going to save somewhere, and that saved data, that measured data, we will apply we applied some algorithm with that data, and after that uh, that helps the reconstruction in the image at the final. So the mathematical using the AIT. So in this slide we will know the what is the mathematical model, or we can say the physics behind this techniques. So this in technique we can define by the Laplace equations, which is written here, So here we have a gamma functions, which is showing the admittivity, which depends upon the positions in the body as well as the frequency of the applied current. So and this U is indicate the applied voltage, and this is the kind of the Laplace equation. So this Laplace equation we can derive from the Maxwell equation, which I have not included in this slide, not included in the slide. So I will explain some the voltage equations, how which are voltage equations which helps which is the type of voltage of the uh, which is the output of our load of the body, which output voltage are giving from the body. So when we are applying the current to electrode on the surface of the body, these currents produce a current density on the surface whose inward pointing normal component in denoted by the J. Means this equation is showing that the current density of the particular electrode uh, which are connected with the body. So the from the current density we can easily we can calculate the current flowing through the electrode, uh, which are we are going to the we can actually express of the elect current from this from the previous current densities phenomena. This admittivity is totally depend upon the body which are going to under test. So so we only applied the current through the electrode, then obvious there is a no current flow between the two electrode, between the gap of the electrode. So that's why the current contributed between the two electrode is here is zero. So here we in the shunt model explain like the voltage which due to the body is equal to the electrode voltage, means the voltage contributed by the load only is the contributed by the load will equal to the electrode voltage, but in but this expression not match with the experimental data because we only including the voltage due to the load or due to the body. uh, we this this model is no this model result is not same as the experiment result, which I will explain in the next slide. So we have told you the earlier equation not meet with the experimental result. So what we have neglected, what we are missing, from which our that equations are not matched with the exact experimental data. So here we fail to explain the electrochemical effect, means we are ignoring the voltage contributed by the by a one small thin layer which has been formed when we are contacting with the electrode to the body. So then the some impedance is formed between the electrode and body that also contribute the voltage of some voltage. So when we include that effective contact impedance impedance result, then the model is called the complete model, that is equivalent to the electrode voltage, the voltage distributed uh, body as well as the contact between them. So this was the physics mathematical model of these EIT phenomena. In this slide, I included this from one of the paper. So in this slide, I wanted to tell you I want to tell you if we are applying the EIT techniques with the some biological tissues. So if we are increasing or changing the frequency of the input uh, input applied current, then how the image we are getting changed and why we are getting changed, means by changing the frequency how we are getting the different image of the same body. So here you can see that this is the image of the carrot root with the different frequencies. In the A diagram, I applied 1 kilohertz frequency of applied input current. So we are getting this type of image. Then if slightly increases, then B type of image, and there is a less shadow. This is all depends upon why we are changing. I will tell you after this slide. And as frequency again changed to 15 kilohertz, this another parts have started conducting, and we are getting some the another type of image. So if we again increasing, then it's decreasing the blue part start decreasing the conducting. So means admittivity of this are changing, or a conductivity are changing. So again, if we are increasing the uh, frequency, so the image are changing, like E and F if we apply 25 kilohertz and 50 kilohertz. So the point is this: why frequency multiple frequency is important for EIT techniques, because we are getting the different image with the different type of frequency. So the point comes, why image are changing. Then we can simply tell the logic behind that is obvious. In the conductivity should change while changing the frequency. So this also can be explained by the another slide. This I have because the conductivity are changing with the frequency. So why and how the conductivity are changing with the frequency, we can understand in this slide. So this also I have included with the another research paper. So here we are taking the uh, some of the biological tissues like potatoes. So there are so many multicellular tissues are connected in the in the biological layer. So here actually each cell can be each cell can be represented as a electrical equivalent circuit, uh, which can you see in this C graph. There are so different type of resistance are showing there, which R1 shows the uh, all cell walls, resistance of all cell walls, and in the same edge the R2 shows the cell membrane resistance, C shows the capacity of all the membrane, and R3 at the last are cytoplasmic resistance of the equivalent circuit. All the actual cells. So we can see from the C diagram, we can conclude the our electrical equivalent diagram of all the cells. All the cells. Here you can see in this diagram we have a parallel RC circuits which are connected in this is R3, and then they are connected with the parallel with the R1. So from this circuit we can conclude that conductivity are changing with the changing in the frequency, because the capacitor value, capacitor impedance are changing with the impedance, with the change in the capacitor impedance changing with the changing in the frequency. So why we are getting the different images? Because every every cells of biological tissues or any material having some kind of the RLC parameters equivalent circuit which change that are changing with the change in the frequency. So if the admittivity or conductivity changes, so our the output voltage will change, or from that we can get the another, we can get the different images from these techniques. So so the conclusion is like this: we have to use the circular electrode geometry or in any application which will give the uniform voltage data. From that we can reconstruct efficient or exact image, if there is an image that is will be efficient image. So if circular arrangement not possible, so we can apply a planar in place of that. And the time multiple frequency image also gives the very benefit output, very different type of the image. This that is really can a good sign for this research, because some of the tissues or some of the tissues may not be conduct with this one in the one specific frequency. So we can also get the output and how they are reacting, how we can understand with the with the some specific tissues with applying with the some different frequency, as and the time difference also changing the electrical properties of the particular tissues or a uh, material. So this all this all conclusion I have made, and I have done the designing part of I have done the designing part of the some electrical circuit, and I have done the coding also. I have done the half coding. Uh, I can do, but it was taking so much time. So I have not included here, but I have done the some coding as well. So thank you very much from my side. Oh, thank you.